Linux container technology that lets us package and ship our applications and everything it needs to execute into a standard format, and then run them on all of our existing Linux hardware. Now that might sound like a virtual machine, and it's a good start for how to think about Docker containers. Docker containers are similar to virtual machines in that our application runs on what seems to be its own hardware instance. Every Docker container has its own virtualized file system, memory, storage, CPU cycles, and so on. Where Docker containers differ is that they virtualize the operating system kernel, not the hardware. That means we can't run any operating system, we have to run Linux. However, we also don't need to install an operating system for every application we want to run. This makes our containers very lean. Virtual machines are much larger because we need to install the operating system, drivers, and so on for every virtual machine instance. We only focus on our application or what's different about a particular instance. Docker does this through a layered file system. Docker starts with a Linux kernel that all containers use. Then it layers the differences on top of the kernel. For example, the libraries for each distro here are layered on top of the Linux kernel. Then apps are layered on top of the distros. Even a command like echo hello world can be made into a container. Compare that to a virtual machine that often requires hundreds of megabytes, even gigabytes. Using a Docker container means we can run many more containers than virtual machines. It also means that we can set up larger environments on a single developer machine. The operating system might be gigabytes, but the differences between our Docker containers might be a few megabytes. This means we can have many instances all on one